Hey guys, this is Sanjay from FTC Team 7477, Super 7. Today, I'm going to be talking about stacks and how to use them in Java. So, let's talk about what is a stack? So, a stack is a fundamental data structure that operates on the principle of LIFO, which stands for last in, first out. You can visualize stacks by imagining like a stack of plates. The last plate you place on top is the first one you take off. In this video, we'll implement the stack in Java from scratch and explore the main things you can do with it. So let's talk about what is a stack. So, a stack is a collection of elements with two main operations. Pushing, which is adding an element to the top of the stack, and popping, which is removing and returning the element at the top of the stack as well. Stacks are really useful in many scenarios, such as evaluating expressions, managing function calls, or implementing undo features in a piece of software. So let's start with the code. So I'm just gonna import java.util. That's not how you spell it. Java.util, just in case we need any of the things. Let's create our class. So we have public, and since my file name is main, it has to follow as well. So public class main. So now let's start coding the functions of the stack. Private int stack. So this is our stack data type. Private int top. This is the int at the top of the stack. And private int capacity, the amount of elements our stack can hold. Now let's create a new method called just stack. It takes in a parameter called size, right? So now stack is equal to new int size. Capacity, oh yeah, the thing we defined before, capacity, it's essentially just the same thing as size. And top, and we have top equals -1 to visualize an empty stack. Oh, it's supposed to be an equal sign, sorry. So we have that equals -1, right? Oh, wait, let me just make it public void so we don't have to return anything. Alright, next, let's move on to our next method, the push method. So, as I described before, the push method essentially just adds an element to the top of the stack, right? So let's say public void push. Public, we want it to be accessible throughout the whole class of main. Void, we don't want it to return anything. So, yep. And our parameter is the element that we want to push to the top of the stack, right? So, let's do some logic. So, if our top is equal to capacity, right? This means that if it's equal to capacity -1, we're just essentially saying if it's full, then we can print out using IntelliJ's built-in shortcut for printing. We can just print stack overflow. Don't confuse this with the name of the popular coding forum. Stack Overflow is an actual is a pretty useful thing when dealing with stacks. It's essentially saying that your stack is full, right? So I'm going to explain the push method a bit more. So in this code, the push method adds an element to the top of the stack. It first checks if the stack is full, which is called stack overflow. If there's space, it increments the top variable and stores the element at that position, right? So I didn't add the incrementing part, but it's just essentially incrementing the top variable and then adding it at that position, which is our element. If you've never had experience with this into-depth object-oriented programming, understanding stacks may be a bit difficult. So yeah, just saying. Next, let's move on to our pop method. So public int pop, we aren't taking in any parameters because it always takes in the first the the thing at the highest value of the stack, right? So we have if our top is equal to -1, then we print out stack underflow, which you may be asking, well, what is stack underflow? So so our pop method, it just removes and returns the top element of the stack. If our stack is empty, we print stack underflow, which is pretty much just saying if it's empty, print out stack underflow. Otherwise, the method decreases the top variable and returns the removed element, right? And now we return. So now we return -1, which indicates that our stack is empty. And then here, we can just return stack of top. Right, so now let's move on to, okay. Now let's move on to our peek method, which I haven't talked about yet. So public int peek doesn't take in any parameters. Well, peeking is essentially just saying that, like, it lets us see the element at the top of the stack without removing it, right? So let's implement this in our code. So if we're using some logic here, if top is equal to -1, which means that if our stack is empty, sorry, then we print out our stack is empty. And then we return -1 to signify that it's empty. And then after that, we just return the top element in our stack, which is return stack of top. Right? Now let's move on to our new method. Public boolean is empty. Pretty much just like, it doesn't take in any parameters. It just signifies whether something is empty or not. So our isEmpty method checks whether the stack contains any elements. Now let's move on to our next method. Let's see. Display, right? So let's do public void display, doesn't take in any parameters. Pretty much just displays our stack, right? So if top is equal to -1, then, sorry, -1, then we print out our stack is empty, right? And then we just add a return statement here. And then we also have more logic, which is very fun. So for int I equals top, I is greater than or equal to 0, and I decreases, and I increments by -1 each iteration. Then we can print out our index of I in our stack, and we can just print out empty string just to like give some space between our indexes, right? Now we can just have an empty print statement here. Right? Now let's talk about our main method. So, you know the drill. Public static void main string and args. So to declare an object in Java, we can take an example from scanner, right? Scanner, and we have our name of a scanner equals new scanner system.in, right? You define it similarly for a stack as well, except, so we have stack, which is, we can just call like our stack. That's, our stack's name is stack, right? And then we create a new, alright, it's too much space, and create a new stack with a size of 5. So now let's like push and do some stuff, right? So we can just declare a stack, and then you can just like run any methods you want with your stack. So let's say we have stack dot push like 30. We can add it to our stack as well. You can also do stack dot pop, and yeah. So this is pretty much just like a basic overview of stacks and their properties. So here we're going to test the stack, right? So in our main method, we create a stack of capacity of 5, and we can push 3 more, we can push 3 elements in total, right? So we can push 10, we can push 20, right? And then we display it, so, alright. And then we can just pop the thing from the top of the stack, right? So using the last in, first out principle, we would know that we would pop 30 out of our stack. So in conclusion, a stack is a simple but powerful data structure with key operations like pushing, popping, and peeking. In this tutorial, we built a stack from scratch in Java, and we tested its functionality and stuff, right? So you may be asking, well, what are stacks used for? And like, how can I use them? How are they meaningful to computer science? Well, stacks are a cornerstone of computer science, and mastering them will give you a solid foundation for tackling more like advanced topics. Thank you guys for watching the Super 7 program tutorial, and see you in the next one.